welcome to another A-Level Computer Science video with me, Mr Goff, from MrGoff.com. This video will focus on sets. A set is an unordered collection of values in which each value occurs at most once. A basic set can be defined by listing all of its members between curly braces, such as here, where set A is comprised of the digits 1, 2, 3, 4, and 5. Larger sets can often more easily be defined using set notation. Don't worry if this looks confusing now. We're going to go through this very shortly. An empty set can either be defined as being a set of empty braces or using the null symbol. The elements of a set are also referred to as members of the set. Let's take a look at that example of set notation from the last slide in a bit more detail. This here means set A is comprised of elements x, where x is a part of the set of natural numbers, and x is greater than or equal to 1. If we break it down further, the pipe means such that x followed by this next symbol for natural numbers means that x is a member of the set of natural numbers. The upwards facing arrow means and so that next to x is greater than or equal to 1 means and x is greater than equal to 1. So that means it's one of the natural numbers and then it's greater than or equal to 1. This would be another infinite set. Some sets are able to be represented using a more compact form. This set here, 0n, 1n, such that n is greater than or equal to 1, means this set contains all strings with an equal number of zeros and ones and where all the zeros come before all the ones. So it would include 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1, and the sequence would continue in this pattern. There are a number of common sets you should be familiar with. Natural numbers are all the positive whole numbers including 0. Integers are all the whole numbers, both positive and negative. Rational numbers are all numbers that can be expressed as a fraction. This includes whole numbers that can be written as themselves over 1. Real numbers are all real numbers. This includes those that can't be written as a rational number, but does not include imaginary numbers like infinity. Notice the way in the examples, 3 dots or an ellipse are used to represent the fact that this pattern carries on to infinity or negative infinity. A finite set is one whose elements can be counted off by natural numbers up to a particular number. For example, a set with 20 elements. An infinite set goes on forever, approaching infinity or negative infinity. As the concepts of infinity and negative infinity are made up, and you can never actually reach them, this means these sets are infinite. The set of natural numbers and the set of real numbers are both examples of infinite sets. A set is countably infinite if, even though it's infinite, we could specify a certain value in the set and it would take a finite amount of time to reach that value. For instance, if we said that we wanted to get to 134,657 in the set of natural numbers, we know that we could get there in a finite amount of time. This is true for the sets of integers and natural numbers, but it's not true for the set of real numbers. The cardinality of finite sets simply refers to the number of elements in a finite set. So if set A contains the values 1, 3, and 5, then the cardinality of set A is 3. The Cartesian product of two sets is the set of all ordered pairs A and B, where A is a member of set A and B is a member of set B. The Cartesian product is pronounced A cross B. So if we had A containing 1, 3, and 5, and B containing 2, 4, and 6, then all the combinations of ordered pairs would be 1, 2, 1, 4, 1, 6, 3, 2, 3, 4, 3, 6, 5, 2, 5, 4, and 5, 6. A proper subset is where a subset is comprised entirely of elements of another set but where there is at least one element in the original set not included in this set. A proper subset is represented by this U leaning over on its side. You can say that the set 0, 1, 2 is a proper subset of the set of natural numbers because there are other natural numbers that are not included in this subset. If the term used is just subset rather than proper subset, this means that the subset can contain all the elements of the other set. This is why the symbol includes a straight line to indicate that it could be a subset or equal to the other set. As well as checking whether a value is a member of a set, there are three other set operations you need to be aware of. The first of these is a union of two sets. This is all the members of both sets, that is, any value that is a member of set A or of set B. Remember that a set only contains each value once, so if set A contains the values 1, 3 and 5, and set B contains the values 4, 5 and 6, the unions of set A and B would contain the values 1, 3, 4, 5 and 6. The intersection of two sets is all the values common to both sets, that is, any value that is in set A and in set B. So, if set A is 1, 3 and 5 and set B contains 4, 5 and 6, then the intersection of sets A and B would simply be the value 5, as it's the only one in both sets. The difference of two sets is all the values of set A that are not also in set B. So, if we have the values of 1, 3 and 5 in set A, and the values of 4, 5 and 6 in set B, then the difference between set A and set B is 1 and 3. That brings us to the end of this look at sets. Join me in the next video when I'll be exploring regular expressions. Use the resources at mrgoff.com to help you revise A-level computer science, and until next time, it's bye for now.